Vamos começar. Ok, já está. Já estamos live. Preciso abrir aqui o PowerPoint.
Estamos no YouTube agora.
Está no YouTube, sim.
Está no YouTube.
Está no YouTube. O YouTube já está a funcionar, já está no live stream. Ok, agora share content.
Eu acho que antes a gente podia apresentar o Miguel, né, Alexandre?
Ah, sim? Ok.
Com certeza, Alexandre.
Quer fazer a apresentação ou eu faço?
Pode fazer o...
Bom, então boa tarde a todos. Obrigado, primeiramente, aí agradecer ao Miguel a sua disponibilidade. Tanto eu quanto o Alexandre conhecemos o Miguel lá em Portugal e convivemos um pouquinho lá em Portugal na área nos laboratórios, frequentando os laboratórios ali. E eu acabei vendo uma publicação dele que ele mandou a respeito da pressão em vasos capilares devido ao congelamento da água, né, Miguel? E aí me interessou bastante, eu falei com o Alexandre para convidar o Miguel para fazer uma apresentação para vocês, principalmente sobre essas questões da pesquisa propriamente dita, né, e esses aspectos relacionados à difusão, e também falar um pouco da experiência, porque o Miguel tem um perfil muito específico de engenheiro pesquisador, né, que gosta bastante da pesquisa, gosta bastante da academia, então falar um pouco a respeito disso, tá? Só que antes de começarmos a falar, é interessante que cada um de vocês abrisse um pouco o chat, começando pelo Alexandre ali, falasse um pouco sobre a sua pesquisa em si, a sua temática de pesquisa, até para direcionar um pouco a fala do Miguel em relação ao tema de interesse de vocês. Então começa com o Alexandre lá.
Boa tarde, então, pessoal. Boa tarde, professor Miguel. Tudo bem com o senhor?
Boa tarde. Viva.
O meu tema é a influência das altas temperaturas em argamassa sujeita à incidência de hidrogênio tardia. Então, um breve resumo do que a gente pretende fazer. A gente pretende simular e fazer com que a hidrogênio tardia aconteça em prismas de argamassa, e depois da comprovação desse surgimento da hidrogênio tardia nesses prismas de argamassa, a gente vai submeter esses prismas de argamassa a altas temperaturas para simular uma situação de incêndio. E aí vamos verificar se essa situação de incêndio ela vai ser prejudicial, se ela vai se somar ao efeito da hidrogênio tardia, majorando esse efeito na nossa matriz, na nossa argamassa. Né? É basicamente isso o nosso estudo. Meu professor é o professor Rogério Antochenes, o orientador.
Ok. Se eu entendi bem, com visa a utilizar, por exemplo, com materiais refratários, não é? Para fornalhas e assim, não é?
Isso, sim.
É isso, ok. Muito bem.
Daniele.
Olá, estão me ouvindo?
Sim, sim.
Tá, meu nome é Daniele. Eu entrei no último processo seletivo e aí a minha ideia é fazer uma análise dinâmica de lajes, tá? Diferentes tipos de lajes. Ainda não está bem decidido, a gente está vendo aí exatamente o que vai ser analisado, mas a princípio seria a análise dinâmica na parte de estruturas.
Ok. Análise dinâmica, utilização, por exemplo, de sensores
Isso.
sónicos, penso que é sónicos, não é? A última, penso que são sensores sónicos que se utiliza mais para fazer análise e estudos de dinâmica em estruturas. Não sei se estou a dizer corretamente, é uma área que eu já não vejo há algum tempo, mas penso que é isso, não é? Ok.
Emília?
Boa tarde, o meu nome é Emília. Eu entrei nesse último processo seletivo e eu vou trabalhar com geopolímeros, que são ligantes alternativos ao cimento Portland.
Ok, geopolímeros. Geopolímeros é importante controlar a temperatura da reação, penso que é o processo mais importante no geopolímero. Portanto, por exemplo, monitorizar a temperatura em tempo real é algo que se calhar é bem pensado, digo eu.
A Evelyn?
Boa tarde a todos, meu nome é Evelyn. Eu não vou abrir a câmera porque eu estou começando a ter alergia devido ao Covid, mas eu vou trabalhar com simulação e análise de vigas. Não foi definida ainda se será concreto armado protegido em situação de incêndio.
Não consegui entender o que disseste, vais-me desculpar, fez muito ruído. Se entendi que ias fazer algum tipo de análise, mas não consegui entender o resto.
Isso, eu vou repetir então.
Sim.
É análise e simulação de vigas.
De vigas, sim.
Isso, só que não foi decidido se vai ser concreto armado ou protegido.
Ah, ok. Pré-tensionado. Ok. Então, em Portugal diz-se pré-esforçado. Penso que é assim, não é? Ok.
Guilherme?
Boa tarde a todos. Eu ainda não ingressei no mestrado como aluno regular, né, no primeiro semestre, como aluno especial. Eu pretendo dar sequência no meu trabalho de conclusão de curso, que foi correção de manifestações patológicas e revestimentos de fachadas, principalmente falta de aderência e soncavo, né? Essas correções elas foram acontecer com injeções de resina epóxi.
Ok. Resina epóxi, ok.
Obrigado, Guilherme. A Isabela?
Tá dando para me ouvir?
Sim.
Bom, meu nome é Isabela, eu ingressei ano passado no mestrado, já estou finalizando ele. A minha pesquisa é sobre deformação, basicamente é o estudo de deformações em prismas com argamassa estabilizada. Essa argamassa é uma argamassa utilizada bastante aqui na região de Santa Maria e Porto Alegre. E aí eu montei prismas para poder estudar deformação com esse tipo de material.
Ok. Deduzo que estejas a usar então sensores strain sensors, não é? Como é que se diz?
A gente instrumentou com LVDT.
LVDT, ok. Também pode ser um LVDT, sim.
Obrigado, Isabela. Isadora?
Oi. Meu nome é Isadora, o meu professor orientador é o professor Alexandre, e eu entrei agora no último processo seletivo, e a gente não definiu ainda o tema, mas eu estou pesquisando para ser algo relacionado a concreto e geopolíticos.
Ok.
Jaqueline?
Pode ser que a apresentação de hoje ajude a definir o tema, então. Vamos lá ver.
Isso. Obrigada.
Ok.
Jaqueline, Jaque.
Olá, boa tarde, pessoal. Meu nome é Jaqueline. Eu ingressei no mestrado no início do ano passado. A minha pesquisa vai ser sobre a influência da utilização de diferentes lodos de estação de tratamento de esgoto na produção de blocos cerâmicos. Eu sou orientanda do professor Eric e o meu mestrado vai ser a continuação da pesquisa que a Tuane Isaac começou.
Ok.
Lidiane.
Oi, boa tarde. Meu nome é Lidiane. Eu entrei no último processo seletivo também, né? Vou ser orientada pelo professor André. E nós vamos estudar, então, a questão de desenvolver essa norma nova, né? Que é a relação de extração de corpo de prova, né? Em parede de alvenaria estrutural cerâmico existentes.
Ok. Muito bem.
Obrigado, Lidiane. Tássia.
Boa tarde, meu nome é Tássia, meu orientador é o professor Girá, e a nossa proposta, então, é trabalhar com a permeabilidade.
Trabalhar com... Não entendi a última palavra.
Fechou o som da Tássia.
Ok.
Tássia.
Eu acho que caiu a internet dela no chat.
Então vamos passar para o próximo, Walter.
Boa tarde a todos. Boa tarde, professor Miguel.
Boa tarde.
Meu nome é Walter, eu sou especialista em tubos de concreto para aerogeradores e eu não tenho um tema definido ainda com o professor Alexandre, mas provavelmente vai ser algo com aplicação nesse sentido, com tubos de concreto, alguma coisa de argamassa ou argamassa colante de elementos.
Ok.
Então essa é a minha ideia, ou algo que surja de nossa apresentação.
Ok. Pode ser que a apresentação de hoje também ajude a escolher algo mais concreto. Vamos ver.
Certo.
Obrigado. Victor.
Sim?
Boa tarde.
Sim, boa tarde. Eu estou a ter dificuldade em ouvir. Não sei se sou o único ou não.
Minha conexão acabou caindo, desculpa. Então, meu nome é Tássia.
Ok.
Eu entrei no programa de doutorado em... Oi?
Sim? Sim. Força.
Perdão. Meu nome é Tássia, então. Eu entrei no programa trabalhar com a permeabilidade de vapor d'água e água e revestimentos argamassados, tá? E tendo como base, tendo como variante a carbonatação desses revestimentos. A metodologia ainda não foi definida, a gente está na fase de problematização do assunto.
Ok. Ótimo. Carbonatação é um assunto importante nas estruturas do betão armado, em particular nas grandes cidades.
Victor, por favor, Victor.
Oi, estamos conseguindo ouvir agora?
Sim.
Tá, desculpa, que antes era tudo no microfone. Bom, eu comecei a entrar também agora, na última turma, e eu vou estudar a influência de bactérias biocimentantes na fissuração dos concretos.
Ok. Eu já tinha lido, aliás, sobre uma bactéria que promovia a reparação do concreto.
Nós estamos
Agora, este é o contrário, não é? Este é o contrário. Esta é que promove a degradação do concreto.
Esta é a bactéria que promovia a reparação do concreto.
Ok.
Esta é a bactéria que promovia a reparação do concreto.
Este é o contrário. Esta é que promove a degradação do concreto.
A minha não, a minha é aqui que promove a correção das subtrações.
Ah, a correção. Ah, ok. Entendi, ok. Tá certo.
Ok.
O Vitor Hugo Kish.
Boa tarde. Eu não sou aluno regular de pós ainda. A minha área de maior interesse é de estruturas. E se eu vier entrar no programa, eu ainda não tenho nenhum tema definido de pesquisa.
Ok, bem-vindo, não é mesmo?
Obrigado, Vitor. A Yasmin, ela está com dificuldade, ela falou com relação ao som. Aí eu vou aqui, meu nome é Yasmin, ainda não me defeito como aluno regular no doutorado, sou aluno especial da disciplina, comércio e engenharia civil, e no meu mestrado trabalhei com investigação do comportamento térmico de argamassa como substituição parcial do agregado miúdo natural com agregados reciclados. No doutorado pretendo trabalhar na área de estruturas de concreto, lajes nervuradas, dentro desse contexto.
Ok.
Obrigado a todos, então. Acho que a gente pode começar, então, Miguel, a fazer a tua apresentação.
Sim, deixem-me só... Vou só ligar aqui o meu Bluetooth, que é para ver se vos entendo melhor. Está um bocadinho difícil. Conseguem me ouvir? Sim, ok. Eu também estou a ouvir. Ok, ótimo. Eu então, se não se importam, eu passava a fazer a apresentação em inglês e vou começar por me apresentar a mim próprio, o que é que tenho feito ultimamente. Se não houver objeções. My name is Miguel. In the past 2 years, I've been working at a startup company in the construction sector here in Belgium. What began to be a simple project management position evolved into a business technology developer after a week or so. And after 2 years, I ended up deploying a logistics platform for construction site management. In the past year also, I've been attending a master degree in artificial intelligence in Spain, and I'm well acquainted with all things related to technology. And as she had pointed out, I'm also enthusiastic, to say the least, all things related to research and the laboratory. So this is what I've been doing in the past year, at least, past 2 years actually. Any questions that you may have during the presentation, feel free to speak up and ask. It's not a problem. Okay, so you can interrupt me at any time, so that because I do tend to sometimes any ideas and any concepts tend to be a bit hard to reach out on my presentations. So if you feel that you are not understanding correctly what I'm presenting, just point it out and I'll try to explain a bit deeper, a bit further about it. Don't be shy. So the presentation today is going to be, as the title says, it's a bit stretched, but I use it anyway. Usages of edge computing in concrete diffusion research. So what is edge computing? Edge computing is a term defined by IBM, and it tries to seek a market where the databases are not stored on the cloud, are not stored on those let's say huge big data centers, centralized, where anyone needs to connect to access the data, but instead relies on the usage of your mobile phone, your smartphone, to store the data locally. That's the main definition of the edge computing. It has many others that derive from the fact that the data is handled locally rather than on the cloud. And this is one of the big topics for the upcoming years, since artificial intelligence requires data to be managed in a more with a more faster pace, in a more speedy way, and for that is going to be needed to be done some kind of pre-processing of the data, if not all processing of the data, for the user to to handle, to react to such data, and so on and so forth. It's also related to what is trying to implement it worldwide, not only here in Europe, but also in Brazil as well, what is known in the news by 5G networks. It's also related to that, and it's also related, for instance, with the worldwide known Tesla car, with its autonomous driving and real-time synchronization of data for awareness of driving conditions, any dangers that may arise on the spot in real time during travel, and things like that. So, to my mind, it's also time for the research in civil engineering to evolve towards that technological needs and give that technological leap to keep up with the trends, with the technological trend that is happening. And it became, I think, very clear with this lockdown and this virus that is still happening, at least here in Europe. So let's begin with the topics that I will be presenting today. I will be, it's going to be a long introduction, but it is as it is because the topics are, it's actually very extensive. It's intended just for, for you to get acquainted with some of the words, some with the terminology, so you can use Google later and look for it and study a bit more if it's in your interest, in your research. So the first thing that I will be presenting is the Internet of Things in the laboratory. I will be speaking a bit about what is the Internet of Things and how it can be useful as a researcher in the laboratory. Next, I will be speaking a little bit, keep in mind these are broad subjects, so next I will be speaking a little bit about machine learning and how it is useful, very useful as a tool for a researcher after the laboratory, but more importantly, if you decide to instrument your experiments in using a real-time approach. It's a real-time approach, meaning if you decide to instrument your specimens, your test samples, and that are connected live to the network, so that you can see what is happening at any given hour from your office, for instance, or at home, for instance, and how machine learning can be helpful as well on that, on that environment, on that technological environment set up for the laboratory. Next, I will be speaking about some software tools and applications that are nowadays freely available on internet that personally I found useful for a researcher. After that, I will be speaking about the nowadays elephant in the room, at least to some, about plagiarism, about copyright authoring, and after all that, how can I use automated text writers to assist me on my writing of my thesis, of my papers, without inferring with intellectual property of others. Okay. And finally, to finalize the introduction, I will be presenting some ideas for those that are find a bit more difficult to write, to put in words what they are observing on their experiments. I will be presenting two good ideas on how to practice and at the same time earn. It's not going to be a salary, of course, but at the same time earn a few dollars at the end of the month with those practicing essays or even articles about science. Okay, so finally, I will be presenting one of the works that I, from time to time, got to delve into, which is the diffusion in concrete. I'm far from it. I'm not an expert in diffusion, but I do understand a thing or two about the process of diffusion, in particular theoretical modeling. To keep things simple, I will be talking about just a little bit about how Kyle David Stanich work presented porosity, or defined it, try to solve the porosity, the study of porosity in concretes, in terms of measuring diffusion in concrete. On his work, he was trying to quantify how diffusion was traveling from one surface to the other by the pore structure within the concrete. And finally, I will be presenting one of my works in regards to diffusion. This one is an early assessment of a formulation that I was developing, and it includes instrumentation and data logging of data, so you can have a more clear view on what can be done at the laboratory using all these technology gadgets that enrich immensely your works, your scientific works, and gives you extra points when you present your thesis at the end. Okay, let's begin by the Internet of Things. The Internet of Things, as is defined on Wikipedia, describes a network of physical objects, of physical electronics objects that are referred as things. Those objects have the ability of sense the environment around them with sensors and software and other small technologies that facilitate the gathering of data and exchanging more so exchanging data between those objects among themselves without human interference over the internet, or over it doesn't need to be over the internet, it can be over pre-configured local network, for instance. Let's say we have a big factory and you want to monitor data on one and both ends of the factory. You can use these devices to connect to each other remotely and using a local wireless network, for instance. Though these gadgets, these things enable real-time analytics, they enable also the usage of machine learning techniques for pattern classification and for doing, for instance, regression analysis. They enable the instrumentation with all kinds of sensors that you can find nowadays on the market, and they can be easily integrated and with simplicity with current systems, with current networks that are now available, not only GSM networks, but also LAN networks, local area networks, or any other system that has that possibility. As the consumer market, the Internet of Things is synonymous with products like smart homes. One example of that is Alexa or Bixby, the Roomba vacuum cleaner, for instance, as well. You also have those smart light bulbs from Philips that allow the owner to change the temperature, the color temperature of the bulb, for instance. Security systems, surveillance cameras. There's also refrigerators that are also connected with the supermarkets and tell and assist the owner, if not do the owner the groceries shopping automatically for the owner, and many others will come in the upcoming years. So the Internet of Things, these electronic devices, these small electronic devices, can be summed up on this information chart. You can, as I said, you can have device connection. They allow data sensing on the environment where they are installed, where they are placed. They enable data communication from the data they are sensing, and also some kind of basic data processing from the data they are collecting from the environment, from the sensors they have installed. They also enable, since they're connecting data, they are very useful for doing data analytics. Once data gets uploaded to the cloud, to the data center, enables later on to perform data analytics on that data. This is where machine learning enters. So this is where you can use machine learning techniques for doing data mining and for doing data analysis, and look for for solutions for the needs and the requests, not only in the laboratory, not only in science, but also when at your employment in let's say in an enterprise, in a company. Enable you to find solutions for the problems, that the company is facing the challenges. So it's not a problem per se. It's now more a challenge that needs to be addressed, that needs to be data mined, and that needs to be studied, and later on applied a solution to it. They also have pegged to him data value. Nowadays, the new gold is no longer oil, it's no longer crude oil, it's that data. And these devices are what are behind this whole data transformation, this whole value transformation in terms of the internet as well. And at the end, they enable us as humans to see more clearly what's around us, the environment around us, and enable us to solve things quicker than ever before, and to present solutions that were not possible to present without this technology. One of the great examples for this is, for instance, the use of artificial intelligent algorithms to 3D print parts that are using traditional manufacturing techniques are impossible to produce. That's one of the major examples one can give when presenting all these technologies. So I've presented a little bit about the Internet of Things, but what is an Internet of Things device? Here it is. This is one example of such devices. This one is a Raspberry Pi. Some of you may already heard of it on YouTube, on Google, around the internet. And the Raspberry Pi, you can see here schematically what enables you to connect and to do with this simple computer. Let's see, for instance, you can connect a memory card, a micro SD memory card. You have USB ports, as you have on a computer, for instance. You have Ethernet connectivity. You have the possibility of audio output, the possibility of connecting to a TV by HDMI port, but the more important thing, the more important part on this device is the one on the top, where it says general purpose input-output pins. Those pins is where the fun starts for a researcher. Is where where this device enables each and every one of you to connect the sensor that best fits your research needs and collect the data, store it on the device, or even transmit it over the internet to your laptop, so you can be comfortably developing your theories, your models, and propose solutions for what you are, for the data that you are connecting from your experiments. I'm not going to be thorough on what these general purpose input-output pins do. Just be aware that you enable you to connect all kinds of sensors and much more to it, and that you can log the data from those sensors. Okay, those who are more into these technical electronical things, you have pulse width modulation pins, you have SPI pins, I2C data transmission bus, and also serial data transmission bus. Okay, this next slide is to present to you the famous Arduino boards that serve practically the same purpose as the last one, but this has the advantage of being a lot smaller and a lot cheaper. Raspberry Pi, to put it in context, the Raspberry Pi is in the order of $30 to $40 a Raspberry Pi. The Arduino starts at around $7 to $10 and are also smaller compared to the Raspberry Pi. Of course, the difference in price also comes with difference in the possibilities on what you can do with it. And the main difference between the Arduino and the Raspberry Pi is the capacity, or the lack of the capacity on the Arduino to do processing of the data locally. You can do some kind of basic processing, but not that much further. Okay. You can see here the Arduino Uno, which is these are the two most common Arduinos, the Arduino Uno and the Arduino Nano. Both of them have digital input-output pins, where these pins is where you can connect the sensors, is where you can connect all the instruments that you will be needing on your research experiments. And in the case of the Arduino Uno, I think this is also an Ethernet port, if I'm not mistaken. So you can connect via Ethernet cable to a local area network. But the main advantage of these Arduino boards in regards to the Raspberry Pi, of course they do serve different purposes, but the greatest advantage of these Arduino boards is the fact that the electronics is modular. The Arduino boards enable you to connect several modules to it and extend the functionalities according to your needs. In here you have three of the most common extension in functionalities in regards to connectivity. You have a Wi-Fi module that connects on top of the boards that I show you right now. You can connect a GPS sensor, for instance, to it. You can connect a GSM board. Let's say, for instance, that you are having your research is going to be on the field, on a building, on a construction site, on a site anywhere, and you're going to need to log some data to it. You can use these Arduino boards, and instead of going every day to the site and check out and to download the data that you are collecting and check if the setup is working correctly, using these Arduino boards, you can do it remotely using the internet at any time. You know if the setup is working or not, and you can, and when it's not working, you can take measurements to more quickly to put it working again. In terms of sensors, these are just another 3 examples of sensors. Of course, you can connect any kind of sensor to an Arduino board. In here, you can see a strain sensor. You can connect a strain sensor to the Arduino board. You can connect a thermography camera for those doing temperature analysis. You connect a thermography camera, for instance. Those doing sound analysis, acoustics, for instance, can use a sound detection sensor, for instance. And these are just 3 simple examples. They are the list of sensors that can connect to these Arduino boards is quite extensive nowadays, and I invite you to look on the internet for the sensors that best fit your needs. For instance, one of you mentioned when you presented your work, for instance, the LVDTs. The LVDT is one of the sensors that you can connect using these Arduino boards, for instance. Okay, so in here I have a small video about of a YouTuber that shows a little bit on how to use these electronics and how simple it is to use these electronics not only in the laboratory but also when working at a company, at an enterprise. There's also a research paper you can see on the left side of this slide by Giovanni Organtini, where he presented some usages of these boards on research that I highly recommend you to Google it and to read it. So let's see the video. Okay, so this was just a simple demonstration of usage of a moisture sensor. Don't be too overwhelmed about the electronics. I don't know anything about electronics or how to connect this. You just need to know simple Ohm's law and where to connect the positive wire and where to connect the negative wire. So that's pretty much it. And next you just need to follow the schematics and read the manual, and you're going to be fine with it. In this part I'm going to talk a little bit about what is machine learning and how can it be useful for a researcher not only after but during the laboratory experiments. So what is machine learning? From Wikipedia, as is defined on Wikipedia, machine learning is the study of computer algorithms that improve automatically through experience. It is seen as a subset of artificial intelligence. Those algorithms build models based on the data that they are provided to them, known as training data, in order to make predictions, to make decisions, without a user constantly providing any kind of input to it. They have some degree of being autonomous on what they are coded to do. Machine learning algorithms are widely used nowadays and have a variety of applications. The most common found on the internet are for filtering spam emails, also for doing computer vision, object identification. Let's say, for instance, in a room, identify where is the chair, where is the table, where is the TV, and things like that, where any other algorithms are unable to perform those tasks. The part of machine learning of interest to a researcher is the one related to statistics and to developing of models after doing data mining and data analysis. And in particular, in the construction, you will find useful for doing, for instance, regression, linear and non-linear regression analysis using machine learning algorithms. One caveat, let's say like that, of machine learning is that it requires more data than traditional methods of analysis require. But don't be overwhelmed by it, because nowadays you can find freely available on the internet data sources that you can use to complement your research work. For instance, let's say that you are collecting data from your experiments, and you can Google those, you can search those open source databases and add to your research data as a complementary data that support the data that you are studying on the laboratory, and with that you can enrich the analysis of your works and why not improve the models that you're using. This is the greatest advantage of using machine learning machine learning techniques for delivering your research at the end with your thesis. Normally on these things we like to define this by steps. This is machine learning is no exception, so you can see machine learning on these 7 simple steps. The first one is gathering data, which you already know how to do it on the laboratory, or nowadays on connecting to an open source database and retrieving the data that you find useful for your project. Next, you prepare that data according to what are your objectives, what are your goals in research. The third step involves to choose the model that performs well, that performs better according to the setup that you have. After the model selection, you are going to tell that model to train on the data that you've prepared earlier. And after that, the model gives you the results, the output, and you can by yourself evaluate those results and eventually do some hyperparameter tuning on the model on the third step, and repeat this cycle until you have the accuracy enough on the results that you can call it a prediction, or you can call it a model, or you can call it a good trend. Common models used, we already know. You already know the regression algorithms is the simplest one, where you have some points of data, and just by looking at it, you find to have a linear trend to it, a kind of a linear behavior. But there are many others. For instance, I present to you here instance-based algorithms, where a decision problem is made with instances or examples of training data that are deemed important or require the model. These methods typically build a database of example data and compare the new data to the database that you already have, using a similarity measure in order to find the best match and make a prediction. Okay, so next you have regularization algorithms that are an extension made to the regression methods, methods that penalize models based on complexity, favoring simpler models that are also better at generalizing. You also have decision trees that construct a model of decisions based on the actual values of attributes in the data, and the decisions fork in tree-like structures until a prediction is made on traveling those branches of the tree. You also have Bayesian algorithms that are useful for problems of classification and regression, in particular problems where data is scarce, where is not a lot of data to begin with, and you need to generate a statistical data set to kickstart your model. You also have clustering algorithms. Clustering is related to how data gathers around itself, how data clusters itself. You have association rule algorithms when you have a set of attributes that define a new relationship with another characteristic of the data set, and you have also as well artificial neural networks that are models inspired by the biology of the brain, and these models are useful, are very good at finding patterns where other algorithms are unable to do. Okay. The downside of this kind of algorithms is the fact that it requires a bigger data set for the results to be more accurate. Okay, but as I said, you don't have to discard these models from the start. You can. I strongly advise you during your research studies to search for those open source databases, in particular those that hold data that are somehow related to the environmental conditions of your setup, in particular outside the laboratory, and you can use that data and towards the objectives on what you are trying to demonstrate with your research work. It's also here another 3 examples of models and algorithms that are nowadays available. You also have deep learning algorithms that are an extension of artificial neural networks, dimensionality reduction algorithms that enable to simplify data and make it more clear in terms of pattern matching, in terms of finding a trend on it. You can also combine different models, different algorithms, and on this particular case they are referred as ensemble algorithms. You can use one model for one particular part of your data set and another model for another particular part of your data set, and at the end you can combine the results towards the objectives, towards the findings that you are trying to look for. Machine learning algorithms, the models, mathematical models, these machine learning algorithms are all based on mathematical models. The list is very extensive. I'm not going to refer all of them here one by one, but I strongly advise you to look on the list that is on Wikipedia. You can Google it as outline of machine learning. You will find there a list of, I'm not going to say all of them, but practically all of them that are nowadays available for each and everyone to use, including a researcher on their studies. One of the main characteristics, and this is not just for machine learning, it also serves as let's say a way of as a part of the methodology of a researcher, is how to work the data set, how to mine the data that you are collecting from your experiments. And this figure, this schematic figure, shows one of the ways on how you can do it. Let's say you have your original data set, the raw data that you just downloaded from your experiments. When trying to find a model, trying to find a trend, usually you divide your initial data set in a training set and a test set. A training set is the part of the data that you select that you are going to use to train the model of your selection. And the test set is the part of the data that is different from the training set that you are going to test the validity of your model. Okay, you can also divide the training set into training set and validation set, and later on to test if the model is actually working as expected with your test sets. During this process, there's a sort of a ping-pong game between the training set and the validation set, where is required many iterations referred in machine learning as epochs to train the model and to tune the model and to evaluate the model according to what are your objectives, on what you are expected to find. And at the end, you get your trend, your analysis, your predictive model of the original data set. In terms of handling the data as well, you can see it schematically, for instance, like is presented on this slide, where you have your raw data and start doing data wrangling, next some data cleaning, after that some data preparation, and only after that you start to pick up your charting skills. Let's say you use Excel, for instance, or your machine learning model, and start to look for a pattern, start to look for a regression, for an analysis of your data. This is where you do your data mining, where you look for your model and at the same time try to validate the data that you have. After that, you can deploy your model. That is to say, you go to your thesis and write the model that you found on Excel or on your machine learning algorithm with your data visualization, with your charts that you find useful for explaining your findings. One of the, as I talked earlier, one of the limitations for a researcher nowadays is having a too small data set to begin with. This is not one of the limitations, not that inflicts only a researcher, that inflicts micro and small enterprises and companies all around the world. And one of the ways that you can mitigate that is by using those shared, open source shared databases in your favor, and include that data in your analysis, in your models, that to enrich the results. Okay, so this it looks like a very out of the loop figure, but it's just for you to to have those keywords for you to include on your Google researches. Don't be scared if you don't know what those mean. Just be aware that if you want to learn more about how to extend your data set, you can use these keywords on Google and look a bit more on how to do it. So this figure is just a simplification on what I've been saying over the slides, where you have those big data databases that are already doing their modeling, their prediction results. And nowadays, some of those, not all unfortunately, but some of those big data databases are beginning to be open source, to be openly available to everyone, and you can use a shared connection, a shared cloud connection, and do data augmentation to your data set, to your small local data set, and do data augmentation, and in turn extend the size of your data to feed to your models, whichever you are working on, and to make predictions on the results. Okay, this is very useful nowadays, and enrich immensely your research work. Just a quick definition of what is data augmentation. As I said, in data analysis, there are techniques used to increase the amount of data by adding slightly modified copies of already existing data or newly created synthetic data from existing data. It acts as a regularizer and helps reduce overfitting when training a machine learning model. It is closely related to oversampling in data analysis. This is the definition you will find on Wikipedia, but in simple terms, it means that you pick up data from someplace else that you find useful for your work, pick it up, make a copy of it, and use it for your work. There are many techniques to use to augment the data set. It is listed here a few: principal component analysis, autoencoding, transforming the data. For instance, in terms of image processing, you can alter the image by changing the contrast of the image, by changing the color set, and things like that. And in turn, you are expanding the size of your data set with those transformations. And there are many other ways of possibilities of augment your data set. Another important key aspect when handling data nowadays, in particular when handling sensitive data, it has to be with how to anonymize the sensitive data so you can share it over the internet. So you can, for instance, do live collaboration with others without losing those private characteristics that you are not willing to give up. There are some, these techniques are just a few that can be used to anonymize the data, so you can live share it over the internet. In cases, for instance, where you are doing a research work that in the end will lead to some kind of intellectual property or patenting submission. these are useful techniques that will assist you on how to better protect your data, and at the same time enable you to use all these technologies over the internet and over the cloud. Moving to the software tools and applications that I find useful and that are freely available on the internet. The first one that is directly related to the modeling of data is the well-known nowadays Jupyter notebooks that you can use by downloading the Anaconda software application for Windows. And the Jupyter notebooks is, as the word says, it's a notebook where you can write lines of code in Python, and at the same time comment ahead on what that code means and what is intended to do, or simply write. You can simply use it to write a small essay, and at the same time test your data set, your models, using the Python language. Another very useful tool freely available to everyone is GitHub. This tool is primarily used by coders and programmers around the world to not only to share and to open source their code, but also as a way to collaborate on coding projects. But this tool can be also used for sharing and to collaborate, writing, using, for instance, Markdown language, LaTeX, even Word documents, DocSheets documents. You can use them on using the GitHub. And the main functionality of this platform is that works with branches, with versioning of the documents, and that allows the different participants on the document, on the project, to work independently and merge their changes along the path of the work. Another platform, another website that I find useful if you are going to use some kind of, not even if it's going to be a 10 line of coding, of programming code, this site, Stack Overflow, is very useful to find answers for the questions that you will find, that you will definitely have during your programming time, and it will expedite immensely on solving many bugs, and on solving not only bugs but also small how-to solutions on how to code this or that functionality, not only in Arduino, but also in Python or any other languages. This is in comparing to GitHub, this is another platform that is worldwide used by coders and programmers, where we all meet and ask questions when we don't know how to do it. We simply ask a question, and sometime after there are users that will reply to your question, answering with their ways, with their points of view on how to solve that problem or that challenge, or how to correct a bug in the code that you are unable to find how to do it. If you are going to take the challenge and use and extend your data set, you are going to need the Python language, and in particular the TensorFlow library to analyze your data. Don't be overwhelmed. This is pretty much the lines of code that you need to build a chart like this one on the bottom using Python and TensorFlow. I'm not going to be extensive here on how to learn the Python programming language, but one thing I will say, it's not a difficult language to learn. It has a very fast learning curve, and for that I will leave to this YouTuber, Cale Hayden, with his tips on how to master Python, for you to have an introduction on this statistical oriented language, programming language, for you to develop this kind of analysis on your data set, and many others. Okay. You can't listen the audio of the video? All of you? That's strange. But you did listen the previous video. Oh, you didn't listen as well. Okay. Okay. Maybe the videos don't go through on the audio. It's okay. I'll leave the. You have the name of the YouTuber. You can Google this video later on. Let me see if I can yeah, it doesn't show, it doesn't matter. You can Google this video. It's how to master Python. It's a 15-minute video. It has some very useful tips on how you can start to learn Python, and in 3 months' time you are ready to write what you are seeing here on this slide. Okay. Next I will be talking about the tools that are freely available for assisted writing, and how can be useful for a researcher in terms of not only automate the tasks of writing, but also to avoid bias on the texts, on the writings that he finds on the internet. So the first one that I'm talking about is referred to as article spinning. The article spinning, as defined on Wikipedia, is a writing technique used in search engine optimization and many other applications, which creates what appears to be a new text, a new content from what already exists. Content spinning works by replacing specific words, phrases, sentences, or even paragraphs with any number of alternate versions to provide a slightly different variation with each spin. Is also known as rogating. What is this good for? Article spinning enables a writer to distance himself from the original text content found on the internet. That's one of the main advantages that I find when using article spinning. It can be used as many times as you want during your creative writing process towards what you are looking to write on your paper. Below you have an example of a paragraph using article spinning. In the left side you have the input, the original text, and on the right side you have the text spinned with a slightly different variation of what was written. You also have nowadays available from the OpenAI framework a text generator. It's known as GPT-2. It's now on the third version. It's already on the pipeline, but not publicly available, only for testers. The GPT-3. And the GPT stands for Generative Pre-trained Transformer. Is an open source artificial intelligence created by OpenAI that uses deep learning to translate text, answer questions, summarize passages, and generate human readable text output on a level that is often indistinguishable from a human, from the writing of a human. One of examples of text generation you will find below. You have a very extensive paragraph using the GPT-2 algorithm, and if you read the text, you will find that it has a good coherence, not only in context but also when presenting reasoning and arguing of an argument. But don't be fooled by all these techniques. These are also techniques that can be traced and that can be identified on the final document. Keep in mind, these are good if you are going to use, in case of the GPT-2, if you are going to use this tool. I'm not saying not to use it, but if you are going to use this tool, you need to have arguing on why you are using it and why it serves the purpose of your work. And the final one is where you can verify if your work, if your writing, is colliding with the writing with someone else, with a plagiarism checker. There aren't many available freely on the internet, but there are some that you can use to check and infer if the text that you are writing is not going to collide at the end with someone else's text. And you can use those plagiarism checkers, and why not ask the university if they have one available for you, so you can at the end, when you present your thesis, be sure that what you are presenting is unique and that no one else is going to bother you just because one sentence or one paragraph is the same as theirs. I strongly recommend you to use this kind of checkers before you hand over your writing. Okay, next I will be talking about publishing early essays or even drafts on during your scientific studies as a way to practice for the the real writing stuff in science, and at the same time, as a bonus, earn some dollars, not much, as I said in the beginning, but at the same time earn some dollars at the end of the month. So the first one is the website known as medium.com. In here you can publish your drafts, your essays, your writings as articles, where you can use this platform as an advantage to you to train your writing skills, because this is not, no one is going to judge your writing in here, and in a way that is going to cause you to feel bad about yourself. You simply present your articles here and let the internet handle the rest without any consequence. The only consequence that you might have is the one at the end of the month, where the users don't click much on your articles, but that is okay, because the main purpose is for you to practice writing of your scientific stuff, of your scientific findings, and so on. Okay, so this is one of the platforms you can use. The other one is Substack.com. This one is the one that I'm personally using right now. And you are seeing now is a screenshot of my dashboard, where you can find, for instance, here I have one of my research studies on piezoresistivity in carbon fiber composites, for instance. The main difference from Medium is that Substack, you can, it's not based on the click, the revenue is not based on clicks, not based on the audience, but instead based on subscription. You can create, an audience that subscribe to your articles, and in turn pay you a monthly or an annual fee for that you can define the value. You can define it as low as, I think it's $4, and go as up as $1,000. You can define the value, and it's a more quieter place for you to practice your writing skills, and at the same time share with your colleagues, share with your friends, share within your network, and get feedback from your friends, from your colleagues, and from your network about what you wrote. That is nowadays the most important thing, to know what others find about what you write, so you can improve your writing skills on that, supported on that feedback, and not alone as it traditional was in the past. Okay, now moving into the laboratory, moving into the research that I've conducted in the past. I'm going to talk a little bit about diffusion in concrete. And I'm going to start, since what was asked of me for today was to talk a little bit about porosity, about what it is porosity, and how it can be viewed or analyzed in concrete samples, in concrete specimens, in concrete structures. And I began to present the definition by Kyle Stanish on his PhD work in 2002, and he began to define porosity by considering these three components of the porosity of the pore network in in a concrete in a concrete element, in a concrete sample, in a concrete specimen. He defined tortuosity. The tortuosity is the twistiness of the pores, with more highly tortuous pores requiring ions to travel a greater path length to reach an equal distance forward. He also defined constrictivity. The degree of constrictivity is the number of size changes within the pores. A generally large pore with many narrow regions would be highly constricted. And the third one is connectivity, that relates the connectivity of a porous medium, how well one portion of the pore network is connected to another portion. The pore network is highly connected if there are many paths to travel from one region to another. You can understand a little bit better on this figure and on the bottom side. The top part of the figure is where you have a liquid medium with differences in concentration and no constraints rather than the liquid medium where it is inserted. And as so, the diffusion process, the exchange on this particular case study by Kyle, it has to do with ionic movement of ions between one region to another, between a region with higher concentration to a region with a lower concentration. And the models that support, typically that support these studies, are considered for a medium where there's a liquid with an area with an higher concentration and an area with a low concentration, and the migration occurs towards the equilibrium between both. But that's not the case in concrete, as we all know, concrete is made of small pores that are connected to each other or not connected at all. And Kyle defined these three components: tortuosity, which is, you can see here by these differences in path, changes in paths; the constrictivity, that you will find here the differences in cross-section of the paths. Some are wider, others are narrower. And the connectivity is here, for instance, where you will find a pore that has no connectivity with others. Okay, so this is the assumptions on his work. This is how we define the pore structure in concrete, and I find his definition, despite being from 2000, a work from 2002, I find his definition still useful today on how to view, on how to possibly view and address the pore structure, not only in concrete but any other material that has a similar pore structure as concrete. Another two things that are important to be considering when studying porosity in concrete structure has to do with the impetus and the resistance to movement. The impetus is the force that causes the movement to occur in migration. In case of migration, this force is the electrical potential gradient. In permeation, the impetus is the pressure gradient, and in diffusion, the impetus is the differences in the concentration of the ion in consideration. The resistance to movement is the resistance that prevents the rate of transport from accelerating indefinitely. There are many factors that contribute to this resistance of movement that are directly or indirectly related to the material, in this case that I'm talking about, referring to concrete, and how the pore network is in reality as it really exists inside the concrete specimens. Okay. You can define, for instance, you can, considering all that I said, you can then define a velocity at which the transport occurs inside the specimen at study. And one way of analyzing it, you can use these simple transport equations that relate the velocity of particles with the resistance and the impetus that those particles find when traveling inside the pore structure of the element in analysis. You will also have the inverse relations, which is called penetrability, and it can be defined like this. Another advance that Kyle did on his work was to define the pore structure by stating that penetrability to be consisted of two components. The penetrability of particles traveling to the solution, and the penetrability caused by the pore structure. The penetrability caused by the solution itself is implying here that particles are more close to the theoretical models of diffusion, of natural diffusion in a medium, in a liquid medium. And the penetrability due to pore structure is the novelty of his work, where he defines those three components: the tortuosity, the constructivity, and the connectivity, to present his findings in terms of the influence of the pore structure on the migration, the ionic migration on his samples. Some considerations about the formulation that he presented. Is stating that penetrability is a dimensionless number, and is indeed related to those components that I just presented right now. Mathematically, this factor must take positive values that are less or equal than 1. A negative value would mean that the pore structure would cause the transport to reverse in direction, which is not a feasible thing. Some considerations on his work about the pore structure. He considers to be made up of a large number of individual pore bodies with dimensions on the order of micrometers. Each of these pore bodies will provide its own modification to the penetrability that the particles experience, and the distribution of these modifications is unknown. He used the central limit theorem to predict the influence of the components that he defined. And in terms of in terms of displaying in terms of meaning in a graphical way, you can see on this figure on the bottom a correlation between the proportion of ions and the modification to penetrability. So this is one of the setups that can be used for analysis of ionic migration caused by a differential in electric current. And he presented on his work this setup to argue what I just referred to. And presented this example as a way to explain in a more concrete way what he was referring in more abstract and more theoretical way. So he applied a voltage gradient of 60 volts over 50 millimeters over 18 hours, and he concluded that the distance of chloride ions would travel in a free solution calculated from the well-known Nernst-Planck equation would be approximately 6.2 meters. And considering his developments on penetrability, the modifications that he included, the ions entering the concrete at the start of the test would reach the far end of the concrete at a distance of 50 millimeters, have experienced during the travel would be 0.0080. That is, those ions will be traveling at an average forward speed of 8 times minus 3 the velocity they would travel in a free solution. So let's consider these 6.2 meters will be traveling at a speed of 1. Considering the setup, the concrete setup on this test, the speed would be only 0.008 times that. Okay. Next, I'm going to present one of my initial experiments towards a better definition and modeling and what is diffusion in concrete. This initial assessment of the work was aimed to study the electrical properties of concrete samples when submitted to the rapid migration test, to determine the average presentation velocity of chloride on the samples at test, and verify the validity of Einstein's Brownian motion on evaluating results, and to compare with the traditional model that is presented on the NT Build 492. Here are some of the characteristics of the concrete samples used. The aggregates, quantity of cement, water binder ratio, and the references used. And so this study was divided into different test duration times. To begin with, you have 4 different mixed compositions, and each of them, before that, this number refers to the water binder ratio, so that it would be more clear the data that is presented. So in this case, the M40 means that you have a 0.4 water to binder ratio. On this case, you have a 0.53, 0.65, and 0.78 water to binder ratio. The test duration times for these samples were divided into 3. And these are the number of hours that the tested was set up to last. On this particular case, I wasn't expecting a total breakthrough of the ions from one side to the other, and so the results were not considered, but is presented here regardless as that fact. So the setup was aimed to evaluate, to log the current behavior, the electrical current behavior that was traveling within the samples with real-time monitoring, the temperature behavior, and the depth and velocity of chloride penetration within the samples. So on this figure you will see one sample already cracked in half, where you can see well defined where at what depth the ions were able to travel during the test. This is the setup and the instrumentation of the samples. As you can see here, there are many wires, and this is because the samples were instrumented with a temperature sensor. This one is a thermopar that was placed from the top to the approximately the middle of the height of the sample, and on the side these are simple electrical wires that travel almost to the center of the sample, and serves the purpose of measuring the differences in electrical current and voltage between contact points inside the sample. There are 4 of them, each are evenly spaced, and then all of this was connected to this is the data logger. All of this has 22 channels. This is a 22 channel data logger, and all of those wires, three samples were tested at the same time, and all of those wires were connected to this data logger that in turn were connected to this computer, and that was logging the data in the hard drive in a Excel file. You know, this was many years ago, but nowadays you can simplify this setup with those electronics that I referred at the beginning. Probably not the wires, not all of these wires, but one of the things I'm sure of it is the fact that you are able now to see the data that these samples are producing in real time without the need to to move to the laboratory and copy the file, go back to the office and open the file and see what has been saved. This has many advantages. One of them is the first one is to see if indeed your experiment is still working and performing well. That's the first one. And the next one is to advance your work using real-time data, and by any chance, if you need to adjust your setup, you can do it on the spot, on the minutes of the data that you arrive, and you are working on it with it. Nowadays, Excel also enables you to load the data from within the Excel. You don't need any special tools for do that, which is a plus. So many great things you can do using live data nowadays. These are the results that I gathered during this initial experimental setup. This this was, as I referred, this was a pre-testing to see how I can, to see how I can use all of these that I had available at that time in my favor towards what I was aiming to develop in terms of modeling diffusion. And one of the parameters that I was trying to see if it was helpful for me was how voltage evaluated inside the concrete specimen during this particular test. And the results are shown now here. In this particular case is for the M78 sample for the 8-hour duration test. And you can see here the voltage measurements of each of these wires, and where are located within the height of the sample. The blue line refers to the probe wire at 30 millimeters high. The clay one is referred to the wire that is at 20 millimeters high in the sample, and the greenish one refers to the top one, which is at 40 millimeter high. And you can see here that the voltage measurements differ from one another as the testing is happening. These are not conclusive enough results, but you can find here some evidence that there are voltage differences as the ionic movement of ions is happening inside the sample specimens. That are this is a good indicator that, for instance, that you can try to study further and try to correlate the ionic concentration in terms of voltage variations within the concrete sample. Okay. You will have here the same results, but expressed in terms of electrical resistance. Here is more clear possible correlation between those two parameters, the voltage and the ionic concentration. And you can see here that the resistance starts to drop at the beginning for the probe that is closer where the ionic movement is starting, and progresses forwards, progresses towards the next probe, which is the one placed at 30 millimeters, and the final one here, the one placed at 40 millimeters. On these results, this is just to show how the current evolved during the setup, during the testing. One particular thing to remark here is this pattern here at the beginning of the test, which does not follows the rest of the data until the end. And this logged data, these results that were observed, most likely will have to do with the polarization with the concrete element itself in the presence of the strong electric field that was applied to it at the beginning. You have here some on the right side as well. You have here some examples of how the electrical current evolved over time. This is for another mixture. This is not the same one. This one is for the test that lasted for 24 hours, and this one was related to a test for 8 hours. On these results, I couldn't find anything of interest, anything that was particular relevant to what I was looking for. Regardless, they are here, and who knows, maybe in the future they will be useful for something else. After those are the results that are retrieved practically without any additional modeling or any mathematical treatment, almost directly from the data logger. And now I present you the differences in velocity that were calculated for each individual sample and for each individual mixture. You also have here the temperature of the sample during the test and the penetration depths of the ions. You can see here that in terms of velocity, the velocities are very close together. They are not as close as I would like them to be, but laboratory do those things to a researcher. It produces results that are those that we are not expected, and we, as a researcher, have to be aware of that. Regardless, if you put it on a spreadsheet and plot a graph on it, you will find to be linearly trended, despite this having only 4 points, which is nowadays it's not enough to justify a linear trend, to my mind. But regardless, it's a good indicator that there is indeed a trend, that this data is indeed trended, and this parameter, the velocity of penetration of ions, is a parameter worth digging a bit more in terms of doing additional research on it. In terms of comparison of diffusion results, this small study aimed the comparison of these two formulas, the one derived from Einstein's Brownian motion and the one presented on NTBuild 492. And from the beginning, you can find that the results are not the same. There are differences, but those differences are not far apart. For instance, the only one I can find here is for the shortest test that has produced a bigger difference in terms of determining the diffusion coefficient, which is also okay because this test is indeed of too short nature, and is also stated on the paper that supports the NTBuild that the duration of the test has to have a minimum time for the test to be considered supported by the model that defines it. So this is it. I hope you like the presentation, and now I'm open to any questions that you may have or any doubts that any time during the presentation arise on the subjects that were addressed. Obrigado. Ainda bem que foi de acordo com aquilo que vocês também procuram. Efetivamente, há grandes vantagens que não podem ser ignoradas em trabalhar os experimentos laboratoriais, os ensaios de laboratório, de forma utilizando a instrumentação, mas com a diferença de se estar a trabalhar lendo diretamente os dados em qualquer segundo ou em qualquer hora durante o dia do trabalho, não é? Isso traz uma enorme vantagem, porque logo à partida uma pessoa sabe que se o nosso trabalho experimental está efetivamente a produzir resultados ou se alguma coisa correu mal. Essa é logo a primeira vantagem logo de imediato, não é? Há muitas outras, mas essa é a mais óbvia. Uhum. Exato, sim, sim. Ok. 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 Uh, Walter, deixe-me só acrescentar, que eu não, por acaso não foi nisso, deveria ter falado e vou dizer agora, que é o Arduino, há a possibilidade de ligar uma bateria, caso não tenha eletricidade nas redondezas, há a possibilidade de ligar uma bateria e em conjunto com a capacidade de transmissão de data através da rede de GSM, poder fazer a monitorização da estrutura remotamente. Sim, a nível da programação, eu sei que muitos de vocês não dominam as ferramentas de programação informáticas, mas não se assustem, não é assim tão difícil quanto isso, e hoje em dia muitas delas são mesmo muito simples. No caso do Arduino, basta saber alguns conceitos muito simples da programação, como estruturas condicionais, if, then, else, e ciclos, como um for, um while, não é? E praticamente, e vocês viram que o código que eu apresentei é efetivamente, são aquele número de linhas de código, não é necessário escrever ficheiros intermináveis de código para se poder ter este tipo de equipamentos no laboratório. Correto. Correto, sim, sim. Ainda tem mais essa vantagem, sim. Não sei se mais alguém tem mais alguma pergunta. Não, é ótimo, ainda bem. Eu aproveito também para dizer que vocês depois têm o vídeo no YouTube para rever e caso tenham dúvidas podem entrar em contacto comigo, não há problema, que eu estou aqui também para isso, sobre estes assuntos, ok? Não se sintam constrangidos ou envergonhados de qualquer maneira. Portanto, basta deixarem uma mensagem e eu, assim que vir, responderei. Um abraço, até a próxima. Tchau, tchau. Tchau. Bom ano, exatamente. Bom ano.